Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the common emitter amplifier. The most common amplifier configuration for a NPN transistor is that of the common emitter amplifier circuit. We had seen previously that a family of curves known as output characteristic curve related to the transistor collector current to its collector voltage for different values of transistor base current. All type of transistor amplifier operate using an AC signal input which alternate between a positive value and a negative value. So, some way of presenting the amplifier circuit to operate between these two maximum or peak values is required. This is achieved using a process known as biasing. Biasing is very important in amplifier design as it establishes the correct operating point of the transistor amplifier ready to receive signal, thereby reducing any distortion to the output signal. We also saw that a static or DC lot line can be drawn onto these output characteristic curve to show all the possible operating points of the transistor from fully on to fully off and to which quiescent operating point or Q point of the amplifier can be found. The aim of any small signal amplifier is to amplify all of its input signal with the minimum amount of distortion possible to the output signal, or in other words, the output signal must be an exact reproduction of the input signal but only bigger or amplified form. To obtain the low distortion when used as an amplifier, the operating Q point need to be correctly selected. This is in fact the DC operating point of the amplifier and its position may be established at any point along the load line by a suitable biasing arrangement. So when it comes to the common emitter amplifier circuit, the single stage common emitter amplifier circuit is shown in this figure, which is known as a voltage divider biasing condition. This type of biasing arrangement uses two resistors as a potential divider network across the supply with their center point supplying the required base bias voltage to the transistor. The voltage divider biasing is commonly used in the design of bipolar junction amplifier circuits. This method of biasing the transistor greatly reduces the effect of varying beta by holding the base bias as a constant steady voltage level, allowing for best stability. The Q voltage or the Q base voltage is determined by the potential divider network formed by two resistors R1 and R2 and the power supply voltage VCC as shown in this circuit. The total resistance RT will equal to R1 plus R2, giving the current as I is equal to VCC divided by RT. The voltage level generated at the junction of the resistor R1 and R2 holds the base voltage constant at a value below the supply voltage. This bias reference voltage can easily calculated using the simple voltage divider formula, that is VB is equal to VCC into R2 by R1 plus R2. The same supply voltage VCC also determines the maximum collector current IC when the transistor is switched fully on, and the base voltage current IB for the transistor is found from the collector current IC and the DC current gain beta of the transistor. The beta value of the transistor is calculated as beta is equal to change in collector current by change in base current, that is beta is equal to delta IC by delta IB. The beta is sometimes referred to as HFE, which is the transistor forward current gain in the common emitter configuration. The beta has no unit as it is a fixed ratio of two current, that is IC and IB. So a small change in the base current will cause a large change in the collector current. So dear students, these are the basic principles of common emitter amplifier. The common emitter amplifier circuit has a resistor in its collector circuit. The current flowing through this resistor produces the voltage output to the amplifier. The value of this resistor is chosen so that the amplifier's Q point, that the output voltage lies halfway along the transistor load line, and the base of the transistor used in a common emitter amplifier is biasing using two resistors as a potential divider network, and this type of biasing arrangement is commonly used in the design of bipolar junction transistor amplifier circuit and greatly reduces the effect of varying beta by holding the base bias at a constant steady voltage. This type of biasing produces the greatest stability, and a resistor can be included in the emitter leg, in which case the voltage gain becomes RL by RE. If there is no external emitter resistance, the voltage gain of the amplifier is not infinite, as there is a very small internal resistance Re in the emitter leg, and the value of this internal resistance is equal to 25 millivolt by current. So dear students, these are the basic principles of common emitter amplifier circuit. So dear students, kindly write down the assignment question. Our question is, write notes on common emitter amplifier circuit. So dear students, see you soon. In the upcoming lecture, we will discuss the concept of oscillators. So dear students, see you soon. Until then, goodbye. Thank you and all the best.